Okay, welcome everyone to our talk on advanced editor tooling for Chapel. I'm Jade, and my colleague Daniel and I are going to be presenting about this topic. Next slide, Daniel. So a lot of modern languages provide a variety of text editor tooling to make writing code easier. And this is something a lot of developers really expect from their editors. And for a long time, next slide, Chapel has only really provided syntax highlighting, and the rest of this kind of has been left by the wayside, like Brad mentioned earlier, that sort of chicken and egg problem. Next slide. With 2.0, we have a number of new tools that cover this. There are two command line based Python tools that cover code intelligence and linting, as well as a VS Code extension to help start to fill in some of the IDE gaps, particularly an IDE or GUI-based debugger to integrate with a system debugger. Perfect. So the first tool that we'll be showing off is called Chapel Language Server, and this provides Dino-based code intelligence. And I'll talk about Dino a little bit on a later slide. But this tool provides all of the kind of code intelligence that you expect from a language tool. Things like jumping to a definition or go to definition, being able to hover over a symbol and view its documentation, inspect generics, and the list here really goes on and on. You can see below some of those features highlighted in this screenshot, and Daniel's going to be demoing a number of these in a few moments. I'll note that a lot of these are off by default as we continue to improve Dino, but you can opt into them with the resolver. And hopefully those will start to become the standard and default so that they are easier to use. Next slide. The other tool that comes with this is ChapelCheck. And ChapelCheck is a linter that catches a lot of common style issues and anti-patterns. This tool can actually be used either from the command line or from an editor. So if you prefer the old school kind of running your tools from a command line to just check things, or if you want to integrate it into a CI, you can run ChapelCheck, or you can plug it in next to the Chapel language server in an editor and see linting code patterns, style issues, as you're writing code. So you can see that here in the screenshot from VS Code, where you're not only seeing these things live, but you're also getting automatic fixes. So this linter can provide the ability to see specific code patterns that are anti-patterns and then actually automatically fix that for you. And again, you'll see that a little bit later in the demo. Something we're not going to be demoing today, but this is also able to be extended. So all of these rules are written in Python, which is hopefully familiar to a lot of users and allows users to extend the linter with their own custom rules, and they can write their own fixits and enforce their own style with this extendable linter. Next slide. So how is this all possible? I already mentioned Dino. Dino is Chapel's compiler front-end rewrite, and there's all kinds of goodness wrapped up in Dino. But primarily, the two things that we care about for this work is the fact that it's a compiler as a library. So it is compiled into its own shared library, which means we can expose it to C++ as an external dependency. And we can use it from Python using some Python bindings that allow us to call into that C++ shared library. The other thing that Dino has is incremental compilation. And that means that after Dino has finished parsing and type checking a piece of code, it will cache some of that information. And so if the same query is run again on the same code, it's not going to get re-resolved. And so that saves a lot of time and means that while the Chapel compiler has traditionally been pretty slow, Dino can be much, much faster and gives you live updates in your editor. So you can see here down at the bottom, Dino kind of takes up this parsing and type checking part of the compiler. And next slide. our new tools, ChapelCheck and the Chapel language server, kind of stick into this part of the compiler. So we're using the same logic as Dino, which is also in the production compiler, to write these tools. So as the language evolves, these tools will get updated as well. Next slide. So I already mentioned the fact that this is written in Python, and this screenshot here is an actual piece of code that's in the ChapelCheck rules that checks whether or not a variable or a declaration has the chapel underscore prefix reserved. And this is not a compiler error, but it is kind of an anti-pattern in Chapel. And so we can warn users when that is the case. And this is a very clean way to write new rules for the linter and allows us to be very extendable. So we can talk all day in slides, but next slide. We'll briefly just show the documentation for how you can get started with all of these tools. And I'm going to hand it off to Daniel to show you all of these things live, because that's much more exciting than slides. Daniel, take it away.
Thanks, Jade. I'm not sure if my microphone is on. Can you hear me? Yes, awesome. Okay. All right, so yeah, I'll jump straight into Visual Studio Code where I'll be demoing this, but the first thing I need to do is actually turn off that resolver feature that Jade mentioned being experimental, because otherwise we're not going to have any stability in some of these examples. Okay. In fact, I'm going to even reload my VS Code window just in case. Okay, cool. So what do you get with the Chapel language server and Chapel linter? Well, some of the most basic features that Chapel has been missing thus far, but we now provide, are hover information and go to definition. And what do I mean by this? Well, here I have this piece of code. This is file.io.chapel. It's a primer. It's basically just a long file with some code in it. And it has lots of different variables and things like that. And previously, like, how would you know what a variable is? You would have to search for it in the file or something. But with the new tooling, you can just hover over this, and hey, there it is, config const example. In fact, if I press Command on Mac, I think it's Control on Windows, and click, I will jump to the definition of that variable and see how it's defined. Of course, I can do the same thing with test file and all these other things. And this actually is not super powerful in variables like this because they don't have documentation. But if I hover over something like I/O, I will actually get documentation for the I/O module right there for me. And I can also go to definition and go to the I/O module. And something I do when I'm bored is I just go through and I command click all these other imported modules and just walk through them. That's not something you really need to do, but I guess I'm proving to you that it works everywhere. Now, another thing you can do, because we now know where all the variables so where all the variables refer to, and therefore where all the variables are. So if I command click this example, I can find all references to example in the code, and I can even go through and look how they're used. Well, apparently they're all being used to select which example is being run in this Chapel file. So the part of the editor UI is covered by Zoom here, but if I now want to rename this, because again, we know where all the symbols are, I can do this easily by clicking rename, and then maybe I'll change this to example number, which is perhaps just a little bit more descriptive of what this variable is. And now if I scroll through, all instances of example have been replaced with example number. Another fun thing you can do, or we can now do using this language server feature, is provide autocompletion for symbols that are available in a scope. So here I'm importing or using I/O, and I/O provides a whole bunch of symbols, and some of them are things like I/O mode. Oh, look, if I type I/O mode, I get I/O mode automatically in my scope. Something that I use all the time is whenever we're using GPU support, but I probably shouldn't try that because I didn't compile Chapel with GPU support enabled. And of course, I can even do fun things like only I/O mode as OI mode. And if I save this now, oh, look, the renamed version of the symbol is appearing as an enum in my code. In fact, I can even hover over it and see the documentation for I/O mode as I imported it. I shouldn't break this file. Okay, and my final piece of fun stuff with just the basic language server features is the symbols outline, which shows you all the variables that are available in the scope. All right, so that's file IO and the basic language server features. Next, I want to move on into a demo of the linter. So I had some code here, but I'm going to delete it. Suppose you wrote a loop like this. For I in 1 through 10, do write ln hello world. And nothing is happening. The curse of live demos. Oh, here we go. Okay. Phew. Right. You'll get a warning that, hey, you are violating a lint rule, that you're not using this index variable. Here, I is not used anywhere in the loop body. Maybe I wanted to say something like this. And if I mention I here, then this warning goes away. But then if I don't, then hey, this is kind of weird. And in fact, there's a better way of writing this program if you don't care about I, and it's just to delete it. So Chapel supports a form of the loop that doesn't have the I in, and it works. And of course, I could do this manually, or I can hover over this linter warning and press quick fix, apply fix for unused loop index, and boom, the warning is gone. Now, one of my favorite warnings, I guess I'll leave that off. One of my favorite warnings about this is, well, look, for all loops or for loops have that written with this do keyword only include one statement in their body. So in this case, I wrote this simple for 1 through 10 loop, and it only has one function inside of it. And if you're coming from Python, you might be tempted to write something like this. And in fact, VS Code is even indenting this code to the same level with me for me. So I can write ln again. And this code, I'm not going to save it, looks like it's about to print hello world again 10 times. But Chapel is actually not an indentation sensitive language, so the do keyword only applies to the first statement below it, which means that this write ln again is actually not part of the loop. And if I save this, I'll actually get a warning about this. Hey, the indentation is misleading. Wow, there's a quick fix. Do I dare? Oh, look, I applied the quick fix. It unindented the write ln because really the write ln is not part of the loop. And now it doesn't look like I'll be printing again 10 times. If I wanted to do this, to do both of these, I'd have to use curly braces. VS Code is not being very cooperative. But here, for 1 through 10, write ln again, and hello, and this will get printed 10 times. A less interesting warning, but that I'll show off anyway, is if you write code that's aligned weirdly, like you're using 4 spaces and 6 spaces for the statements in the same scope, you'll also get a warning. And to fix this, you either indent one of them to the same level or unindent the other. All right. And I guess the final thing that I wanted to show off is the casing rules. So here maybe I'll write, oh, maybe even we showed off earlier the rule for disallowing the chapel underscore prefix. So if I write var chapel my thing equals 42, I should get a warning. Yep, I do. And then maybe I'll even write ln this chapel my thing. Look at that. Okay, so I have this variable. It's not named properly because the chapel prefix reserved rule is being violated. Now, this rule doesn't have a quick fix because picking a new name for a variable is something that's kind of hard to do automatically. But what I can do is right-click over this, go rename symbol, take off the chapel prefix, it gets replaced everywhere, and the warning goes away. So that basically shows you the power of the chapel linter. And again, I kind of want to show off the rules again. Most of these rules are super simple, written in Python, and you can write your own rules for patterns in your chapel code that you want people to avoid. Okay, so now for the part of my demo that's more experimental and makes me a little nervous, I'm going to turn the resolver back on, but of course, Visual Studio Code has reset my settings view. Where is this? Where's my resolver argument? Am I just going blind? Huh. Well, let me try that again, but that's, there it is. Found it. Okay, right. So oh, like, look at that. Okay. So as Jade mentioned, these are off by default because of stuff like this, where it's not uncommon for the resolver to crash. I will reload VS Code and hopefully only open one file, which in the past has worked. Yay. Okay, we're good. So I think there were some files open in the background that were causing the language server to crash. But we've closed those and we're back with a working file. Right. So the reason that I'm showing you this file is because there's a really common pattern, or a relatively common pattern in Chapel code, where you specialize what a function does depending on the type of its inputs. So here I have a generic function, and it checks, or it gets a variable x, and this variable x is just generic, and it asks, does this type support an efficient implementation of whatever operation that I'm doing? And if it does, then it uses the efficient operation. And if it doesn't, it uses the slow operation. And in this case, I implemented the efficient operation only for integers. And in this case, I'm modeling the efficient operation by returning 3.14. Meanwhile, the slow operation works for any type. Note that its input is generic, but it is slow. And I modeled that by returning 3.0 plus 0.14. In practice, I don't think there's going to be a performance difference between these two. But it's just kind of a semantic encoding of slowness, I guess. And then my type supports efficient operation query over here just checks if the type is an integer, and therefore whether it can be fed to this function. So then, okay, I've said all this stuff, and now imagine you're debugging this generic function, and you're trying to understand what's going on. You don't even know like what branch of the code is being taken when you have a certain input. So type supports efficient operation is potentially simple in some cases, but not necessarily simple in others. So what we do is provide a way to view generic instantiations using the language server. So here I will click the show instantiation button, and all of a sudden, oh look, it's telling me that X is a type int64. That corresponds to this call over here. And because of this, type supports efficient operation is true, which means the else branch will never be taken. So it's greened out like a comment here. Meanwhile, do efficient operation is taken. So I know that when my input is an int, this branch is dead and this branch is not. And then if I do show instantiation.
Daniel, I'm sorry, I'm gonna have to interrupt. We're coming up on time for this talk. So if anyone has any questions, we might want to take them and make sure we have enough time for a break as well following this.
All right, sounds good.
Does anyone have any questions they'd like to ask? We just have 1 minute left before we have to go on break. If needed, people can ask questions. Oh, Tiago asks, is it available?
Why, yes. Yes, it is. So available, I guess, has two meanings in this case. Since 2.0, the Chapel language server has shipped with the Chapel release tarballs. So if you download the Chapel source code, you should have access to the Chapel language server and the Chapel linter. However, for instance, if you're using Homebrew, we weren't bundling Chapel language server and Chapel check with the Homebrew installations prior to the upcoming 2.1 release. So it's available. If you have the source code, you can build it. If you're not using Homebrew, you're probably building it from source anyway. But if you're using Homebrew, then after 2.1, you should be able to even just get it using brew install. But you'll get it with Chapel.
All right, perfect. Well, since we are at time, I will ask people if they have any more questions. They can ask them in the chat or come off mute. But as of now, we are during our break time. So, take a break, go take a walk, have some water. We will resume at 9:30 Pacific time with the second session of today. Thank you so much, Daniel and Jade. It was a fantastic talk. And we're really excited about the debugging and developer features available in Chapel.